Hello everyone, welcome to another video of our universal gate. In this video we will discuss about NOR gate. In the previous video we discussed about what is universal gate, what are the advantages of universal gate, how many types of universal gates are there, and what is our NAND gate. Now in this video we will discuss about NOR gate. So let's begin our video. It is the logic gate whose output is high when all the inputs are low. NOR gate inverts the result of OR gate, so it is named as NOR, that is not OR. The first letter of the NOR gate represents the NOT gate, so it is named as NOR. Symbol of NOR gate. Before going to symbol of NOR gate, you can see from the definitions of the NOR gate, it is the combinations of NOT gate and OR gate. So we will combine our OR gate and NOT gate to draw the symbol of our NOR gate. This first part represents OR gate. Here A and B is the input of OR gate, whereas Y is equal to A plus B is output of our OR gate. Output of this OR gate has to be inverted. To invert this output, we connect this output to the input of our NOT gate. The second part represents our NOT gate, where output of our OR gate is connected. That means output of OR gate is input of our NOT gate. And the combinations of this first part and second part can be equivalently represented by the diagram in a digital logic as this one. A and B are the inputs of OR gate, and the small bubble is present. This small bubble represents the second part, that is our NOT operations, and Y is equal to A plus B complement represents the output, final output of the first part and the second part. Come to the truth table for NOR gate. The total number of possible combinations for the input is given by n is equal to 2 to the power small n, where this small n represents the number of input. In our case, we have 2 input, which is equal to 4. So the number of possible combinations is equal to 4. The 4 possible combinations of the input are 0, 0, 0, 1, 1, 0, 1, 1. In the table, this A and B represents our input. Column number 3 of truth table is output of our OR gate. It is output of our first part, and output of this first part is inverted by using a NOT gate, and this will be the result of our NOT gate. Hence these columns will give the output of our NOR gate. As you can see, the output is high when both the inputs are low. This is exactly the definitions of our NOR gate. You can see in the first point, the logic gate whose output is high when all the inputs are low is our NOR gate. Now we move towards logic gate simulator, where we will verify the combinations of this NOT gate and OR gate actually gives the NOR gate. Here is my logic gate simulator. First of all, I need an OR gate. This is my OR gate, and I need 2 input for this one, input A and input B. This will be my 2 input for my OR gate. And also I need NOT gate, where I will connect the output of OR gate, and this will be my final output. I will rename it as A, and this will be my output Y, and this will be my input A, and this will be my input B. Likewise, I need NOR gate, where I will compare the results of the combinations of OR gate and NOR gate, and this will be my input, this will be my output. Now I will connect all the inputs to its respective gates. Here I have connected 2 input A and B to my OR gate, and output of OR gate I will connect it to input of my NOT gate. I have connected it here, and the output of NOT gate to the final output here. Likewise, I will connect my input A to my actual NOR gate. Here I have connected. Now as you can see, in both the cases, when A and B are low, output is high. Now I will make one of my input high. Let's make it A high. A is high here, A is also higher. You can see both the output is 0. Now I will make B as high. When B will be high and A will be low, you can see that the output is also low. And when both the inputs are high, then also the output in both the cases is low. Hence we verify that the combinations of OR gate and NOT gate gives the result of our NOR gate. So it is named as NOR. That means not OR. Come to the timing diagram of NOR gate. We know that timing diagram represents the graphical form of inputs and its output. In this video we are discussing about two input NOR gate. So suppose two inputs in its graphical form be input A and input B. Here you can see the number 0 and 1. This 0 represents the low and 1 represents the high. And in both the input A and B, the value of inputs are changing in certain point. We have to figure out the point where the value of input A and input B are changing. I've drawn a red dot line here. This red dotted line represents the point exactly where the input A and input B are changing their values. Now from the truth table of the NOR gate, we will be able to draw the graphical representation of our output. This is the truth table of our NOR gate, where you can see the output is high only when both the inputs are low, and rest of the cases you can see the output is low. On the basis of the truth table, we can be able to prepare the graphical representation of our output. Our output will look like this one. I will explain it here. You can see when both the inputs are 0, here you can see both inputs A and B are 0, output is high. You compare it to our truth table here, you can see when both the A and B are 0, output is high. Likewise, when both the input output is 0, and also when A is low or 0 and B is high, that is 1, output is 0. You can check each and every results in the truth table. For rest of the red dotted line, by same process you will be able to prepare graphical representation of our output.